There's no school tomorrow.
I think we'll have a quiz on Monday.
Saturday morning. I did that last week.
All right, so today we're factoring ax squared plus bx plus c quadratics. Okay, so basically I could write a sentence here. My sentence says having a leading coefficient other than 1 complicates factoring. And then I say we will use the AC method. Well, guess what? You've already been introduced to the AC method. So let's just do some problems, shall we? So here we go. Factor is the instructions. And we've got 2x squared minus 13x plus 6. Always check and see if you can factor out a monomial first. Can you? You cannot. That 13 messes it up, doesn't it? So we're going to factor using the AC method. Hey, I should say, not all quadratics factor. So in reality, when you come across these, more often than not, you'll try to factor them, and then they won't. And so you have to solve it a different way. We'll learn those other ways that you can solve it. But I just wanted to clarify that point that they don't all factor. Oftentimes you'll start the AC method, and then you know how where you factor out the monomials and they're supposed to match. They'll often not match, and you're like, oh, okay, well, that was a waste of time. Well, ladies and gentlemen, to do the AC method, you got to multiply A and C together. What do you get on this one? 12. What two numbers multiply together to make 12 and add together to make negative 13?
12 and 1. 12 and 1.
Negative
12 and 1.
They have to be negative.
But both of them will have to be negative. Yep, that's what's going to happen. And then split up the middle term. By the way, a common mistake is when people split up the middle term, they forget the x. Don't they have to have x's to add up, right? And then we factor by grouping, which means we're going to group the first two terms together. And what do I always insist you do before you group? Plus a negative, and then group those. What can I factor out here?
X to the times 2x minus 12.
Oh, well, we could take a 2 out as well, though.
Yeah, 2x.
A 2x, yeah. So it'd be x, what?
Minus 6.
Oh, wait, nice.
Yeah, there we go. What's the only thing I have to take out here? A negative 1. Whenever there's a negative, you have to factor out the negative. But that's it, isn't it?
Yeah.
How does that change things?
Make
X
it
and
minus
6
6.
cancel out.
Well, make it a positive x and a negative 6. Yeah. Right? Factoring out a negative, we'll just change these signs here. Pretty cool. These match. We're in luck, aren't we? So you factor out your common binomial, and what's left over? 2x minus 1, and you are done. The reason we're done is because it said factor, right? Yep, no solving involved. Well, let's try another one. 8n squared plus 22n
We're just factoring this one too.
minus 6. Yeah, I'll let you know when we mix it up. Always check if you can factor out a monomial. Can you?
4n squared plus 11n minus 3.
Oh, because you can take out a 2, can't you? Don't those all have a factor of 2 in them?
Yeah.
So it'll be, Jasmine was saying 4n squared plus 11n minus 3. Right? And you divide that 2. Okay, now here's the thing. That 2 is going to hang out till the very end. It's just going to hang on. Yeah. I suppose. You're going to miss some notey notes. Yeah, you good? Okay. Well, ladies and gentlemen, we still have a quadratic. Let's see if it factors. Let's do the AC method. What's our AC?
48.
Oh,
Negative 48.
48.
Negative 12.
And we're not looking up here, we're looking here now.
Wait, why did I do that?
Yeah, negative 12. Yep, look down here where we're at.
Wait, why did you do that?
Oh, we factored out a monomial. Whenever you're asked to factor, you always want to check if you can factor out a monomial first. If you don't factor out a monomial, you're not actually factoring all the way.
So why couldn't you just do the AC method off the start?
You could, but what would happen is at the bottom you would still have to factor out a monomial.
Oh.
I'll show you, okay? I'll show you, Marcel.
Can you just ignore the N2?
Ignore it. Well, for the AC method, you just got to look at the number out front and the number back here. And, I mean, we're not going to ignore it. It's going to come around later.
Right.
What two numbers multiply together to make negative 12, but add together to make 11?
Negative 1.
12 and negative 1. And so let me just double check. Yeah, that works, doesn't it? So now we're going to rewrite it, but we're going to split up the middle term. And what you can do is keep that 2. It's just going to look a little weird, okay? So we still have this 2 out front, don't we?
Why is it not, why?
Well, because it's there. So I'm just making sure that every line has everything. If you want to, you can leave the 2 off and just make sure to have it at the end. But I'm just showing you what it looks like if you keep the 2.
So if you factor, or if you do the same with the monomials, you have to put that number on the outside.
Yeah, it's gonna be part of your answer on the outside. Let's group it. What do I have to do with this bad boy? Plus a negative, right? So it kind of looks weird because I had this big set of parentheses and now inside I've got these little parentheses. But all this is doing is keeping this 2 out of the mix. It's keeping it on the outside. What can I factor out right here? 4n, right? What does that leave behind?
N plus 3.
n plus 3.
What happens to the 2?
Oh, I'll bring it in here in a second. What can I factor out here?
Negative 1.
A negative 1 again, right? What does that leave behind? N plus 3. And then what was outside of all this?
2.
2. Isn't that wacky? Now this looks like a mess, but we're almost done. What common binomial do we have?
N plus 3.
So we take out an n plus 3, and what's left behind? 4n minus 1. And what was on the outside of all of it? 2.
Wait, that is.
And we're done.
Wait, you don't distribute the 2?
No, because we're factoring, man. Distributing is the reverse of factoring. Yeah. Yep. So we factored out a monomial, and that 2 just hangs on, doesn't it? While we factor doing the AC method. Okay, well, let's keep going. Yeah, we're good. Check out this bad boy. Negative 2y squared minus 5y minus 3. Here's the thing. Whenever there's a negative out front, always factor it out. Whenever you see a negative out front, always factor out a negative 1. Are you guys with me on this? The reason why is you'll still be able to do the AC method, but on certain sign relationships, the answers won't work out. Or it'll work out, but it'll give you a wrong answer. if you always get rid of the leading negative, the AC method will always work for you, okay? So we're going to factor out a monomial of what? -1. How is that going to impact it?
Make it all positive.
You got it. And now we're going to do the AC method again. And what's going to happen with this -1?
It's just gonna go all the way.
Yeah, it's just going to hang out, isn't it? Okay, so I'll be quiet and you guys can work this out as well. I'll take roll real quick. When you're done though, take a look and make sure you agree. And I might have made a mistake, so always double check me. What do you guys think?
It's right.
Are you good? Yeah? Is factoring out the monomial out front bothering you too much, or is it okay? What?
I don't get the last step.
What do you mean none of it makes sense? That's quite the statement, Nancy. None of this makes sense. I'm sorry, what do you mean? So, yesterday's made sense, but today's doesn't?
Yeah.
Yeah. So the only difference is I guess this isn't factoring the monomial out.
No, I don't know, where'd you get 2y plus 3? Like, I know where the plus 3 came from. Where
Right here.
I got it right.
Is that what you're talking about?
No, down at the bottom. Yeah.
Oh, because when you factor out the common binomial, you're bringing it out to the front, but then what's left behind?
2y and
2y plus 3. Yep. Yeah.
Okay, I cannot understand where in the world you got y plus 1 from. I'm like so confused.
When you factor out a monomial here, you can take out a 2 and a y.
Oh, because you divide it. Oh, I forgot to
Divided, yep.
divide.
You forgot to divide? Okay, okay. What do you guys think? You ready to knock out a few more examples?
Just very last step.
Well, we're also going to solve.
Yeah, well,
So from here to here. See how you got a y plus 1 and a y plus 1? Think of this as like an x. Think of this as an x. If you have 3x and 2yx, they both have an x in common, and you can reverse distribute and take the x out. But it's not an x, it's a y plus 1 and a y plus 1. You're going to reverse distribute. You're going to take it out front, and then it's gone. And what's left over is a 2y plus 3.
So if two things are the same, you just gotta put them out first.
Put them out front? Yeah, you're actually factoring them out front. Okay, well, let's try another one.
I have a question.
Yeah.
Okay, does it matter the order? Because what I did is,
it doesn't matter.
well,
Yeah.
I did 2y squared plus 3y, and then I did 2y plus
That's
3. But if you went to divide those, you would get like
Yeah.
3 over 2.
So you should end up, well, yeah, something else might be going
You
on.
can
I don't know what
factor
you
out
did.
y, you factor out 1, and then you get...
Yeah, okay.
Mr. Eichen, would it matter if those were flipped?
What?
Would it matter if those were flipped?
It wouldn't. It wouldn't.
When you get to here, you can factor out y, you can factor out 1 from this part, you can factor out here. And both things in the middle of the block. It's right here.
Yeah.
You factor out y from there.
Okay.
Left with 2 y, and both here, you're gonna
Before we
factor out 1.
Before we move on, let me show you what Kylie's talking about. And let's just zero in on this 2y squared. If we had said 3 and 2 instead of 2 and 3, you might have written this as 3y plus 2y, right? Plus 3. And yeah, we do need to talk about this because I don't know if this has come up before. When you go to group these, right? And this is called factoring by grouping. Group the first two, group these. What do these have in common? Y. Leaving behind a 2y plus 3. Now here's where things get weird. Is there anything you can factor out here? So there isn't, but you're going to think of it as you're factoring out a 1. Because if you don't write anything out here, you're going to probably mess up the next two steps. So go ahead and say, oh, nothing in common. Well, I could write a 1 out front, can't I? Is that going to change its value? No. So it's good. It's good. Now, do you see how you got a 2y plus 3 in common?
Yeah.
Factor out that. But here's why it's so important to put the 1 there. What's left over? Y plus 1. What happens is if people don't put the 1 there, they'll just write y. But it's y plus 1. And do you guys see how that does match this? It's just the order's different. And that's okay with multiplication, isn't it? And of course we had a -1, didn't we? So we were just zeroing in on that. So if your binomial has no common factors, what are you going to write out front?
1.
A 1. And then it works out nice.
Okay.
Yeah, you could have done it like that.
That makes a lot more sense than whatever that was.
Okay.
Well, see, 'cause I did 3 and 2. Okay, that makes more sense.
All right. Okay, so ladies and gentlemen, switch in instructions. The instructions are find the zeros. Find the zeros. And we've got function notation again. So here we go. F of x equals negative 9x squared minus 39x minus 12. If it says find the zeros, what it's asking you for is the x-intercepts, where the graph crosses the x-axis. And where that is where y's value is 0. So when it says find the zeros, what do you put in f of x's spot?
0.
You're going to put a big fat 0 right there. You're going to put a 0 right here.
Don't all those go into 3.
Say what? I'm sorry.
Don't all those go into 3.
Oh yeah, I think you're right. So a 3 goes into all of them. And what else do we have to take out?
Negative.
Yeah, very good. Let's go ahead and do that.
-3.
So we take out a -3 and then carefully divide to find out what's left.
3x squared plus 13
Plus 13.
plus 4.
Plus 4. Nice. And what's our AC?
12.
12. What multiplies together to make 12 but adds together to make
12 and
13?
1.
12 and 1. And so we'll have 3x squared plus 12x plus 1x plus 4. And what's waiting out front?
Negative.
-3. Also, don't we also have equals 0?
Don't you have to add?
Factor by grouping. Group the first two. Group the next two. What do these? What monomial comes out of 3x squared plus
The
12x?
3x.
3x does. Leaving behind
The x and the 4.
x plus 4. Back here we are again. What comes out of 1x squared plus 4?
1.
We're going to write a 1. And do you guys see how that 1x isn't really needed? You can just write x plus 4. Okay. And then what's on the outside of all this?
-3.
A -3
0.
and a 0. Now that these match, we factor out the common binomial, so x plus 4. What's left behind?
3x plus 1.
3x plus 1. What was out front?
-3 equals 0.
What's out in front of that?
0.
Equals 0. So what's left is we need to actually solve this, don't we? So this -3, you can handle a couple different ways. One thing you could do is you could do the zero product property and say -3 is equal to 0. But does that give you a reasonable answer? Does that even make sense? So you would just throw it out. That didn't make sense, did it? And then you'd also set x plus 4 equals 0 and 3x plus 1 equals 0. Another way to handle it is you could say, oh, this -3, I'm going to get rid of it. I'm going to divide both sides by a -3. And if you do that, now you're just left with x plus 4 and 3x plus 1. That's your two ways to handle that
Divide any number.
What's that?
Can you divide any number?
Yeah, you sure can. Yeah, as long as you do it on both sides, right? So either way, do you see how that -3 is not going to get you an answer? It's either going to get you a bogus relationship or it's just going to go away. Any way you want to handle it is fine. Are you guys comfortable going straight to the answers right here?
Yeah.
What's one of our answers going to be?
-4.
But what's the other one?
-1/3.
-1 divide by 3, right? Is everybody solid on this? If not, you're going to want to write 3x plus 1 equals 0 and work it out, right? In order to get your answer. Okay, so a lot going on. We still got like 7 minutes until lunch, don't we? Shoot, dang. Yes, feels like we've been here for like 3 years or something. Yeah. All right, let's put another one on that you can try to work out. Solve. And let's go -10x squared minus 15 equals -35x. Yeah.
I guess let's do seven.
Oh, wait, I haven't worked it out yet, so I guess I'll work it out.
Can we like rearrange the order so they get 15s on the end?
You sure can, and I would recommend that. Yeah, I think that's what you should do. I think I've got answers. Hopefully I did it right. So when you're done, raise your hand and I'll come by and check. Ooh, close. Right here. Let me move it over. Yeah, it's gotta change some signs. Yeah. So I don't agree with that. Okay, all right, yeah. You good. Say what? Oh, you know what? Factor out more than a negative one. They're all positive. So you can also that would make everything sense. Easier to do. Uh-huh.
I got 3.
Looking good, you just gotta keep going because it's solid. Yeah, you're good up to there. Oh, okay, no, you're right. Well, but check it out. It became a positive. So I think you're gonna need to divide positive 35 by negative 5. I think it's gonna be negative 7. So. Hey, once I